Hello everyone. This lecture we are going to learn MPLS basic principle. MPLS stands for multiple protocol level switching. So MPLS at the beginning it is produced to speed up the data forwarding because we know our traditional IP forwarding we must need to search the IP routing table. And when we search the IP routing table, we must use the longest must match to search the IP routing table. So it takes a long time to forward the IP packet. So we produce the MPLS to help us to speed up the data forwarding on the devices. So this lecture, we are going to learn the two plans of MPLS. One plan is control plan. The other plan is forwarding plan, or we can call it data plan. Okay. So control plan, you can think if it is in IP network, the control plan is a process that we build the IP routing table. So control plan is a process to build the table. In IP network, it's a process to build the IP routing table. In MPLS network, it will be the process to build the MPLS level switching table. That is control plan. After we have built the table, we need to forward the data, right? Okay, so we will go to forwarding plan. In the forwarding plan, if it is IP network, it will be the IP packet be forwarded by the IP routing table. We search the IP routing table and forward the data. And if it is in MPLS network, it will be like we will search the MPLS level switching table and then we forward the MPLS packet. So you just remember all of the all of this lecture we will follow these two plans, control plan and forwarding plan. Okay? So upon completion of this course, you will be able to describe the background and typical applications of MPLS, describe the basic concepts and working principles of MPLS, describe the process of MPLS data forwarding. First, let's look at the MPLS overview. This is a traditional IP forwarding, and on router A, B, C, D, we have a packet on router A, received on router A, and the destination is 10.2.0.1. So how do we forward this data? We will search the IP routing table, and we will use the longest must match principle to search the IP routing table to find the destination and to find the next hop. Then we will forward it to the next hop. So router A will give it to router B. So on router B, we will do the same process, the same action, search the IP routing table, find the next hop, and then give it to next hop. On router C, also give it to next hop. Finally, on router D, we search the IP routing table, find the next hop, and give to the destination network. So this is the traditional IP forwarding. Because at the beginning, the performance of the physical equipment is limited, and the IP routing table is very large. And if the IP routing table is too large, it will reduce the processing time of the physical equipment. That's why we need to think about a way to speed up the forwarding speed. Then we produce the ATM technology. ATM technology means asynchronous transfer mode. On the ATM table, we don't need to care about all the destination networks because packets they may want to go to different destination. So we don't need to maintain this table. We just need to maintain the table with the label. That's the label only help us to go to the next hop. So this reduces the size of the table because the table is small and the forwarding is very simple. So in this way, it can help us to speed up the forwarding speed of the data. So MPLS is like the IP forwarding and ATM together. We produce the MPLS. So MPLS, we use label to forward the data. And if we have a data, and this data have an IP header, and then we will add a new header, MPLS header, to the traditional IP packet. So in the MPLS domain, we don't need to check the IP header. We don't need to check the IP header, check the destination IP to check the routing table, forward the data. We only need to check to process the MPLS header. In the MPLS header, we will have the labels. So we will search the MPLS label table to search the table to find the next hop, then to forward the data to the destination. So this is MPLS label forwarding. Let's look at it. When router A receives an IP packet, because router A is the ingress of the MPLS domain, so the router A, it will push a label, MPLS label. This label is MPLS is contained in the MPLS header. So this label is 1024 and send it to router B. When router B receive it, it will search the MPLS label switching table. And because the incoming label is 1024, so he searched the table, he will find the outgoing label is 1029. So he will swap this label to this label and then forward it to the next hop, router C. When router C receive this packet, he will process in the same way. The incoming label is 1029. He will swap the label to 1039 and send it to next hop, router D. And when router D receive this, he search the label switching table. He find the incoming label is 1039. The corresponding action is pop. So he will remove this label and send it to the destination. When router D send it to the destination, it will use the IP forwarding again because router D is the egress of this MPLS domain. It means router D is the last hop of the MPLS domain. Okay, so this is MPLS label forwarding. And nowadays, because the performance of our equipment, the performance of the router, performance of the switches is very, very good. So we don't need the MPLS to help us to speed up the data forwarding because it's the same. Even if we use IP forwarding, the speed is the same with the MPLS forwarding. So MPLS now it will be used in some VPN application. For example, MPLS VPN. So in this MPLS domain, it's always be the ISP. So in the ISP, we have different customers. So these customers, they have the requirement to communicate with their remote site. For example, customer A, this is the headquarter of customer A, and this is a branch of customer A. So they have the requirement to communicate with each other through the ISP, through the internet. So they will purchase the MPRS VPN from the ISP. So that is the application of MPLS. And we can use MPLS VPN to distinguish different enterprise and different VPNs. Another application is MPLS TE. TE means traffic engine. So with MPLS TE technology, for example, we can control the traffic to go to use the different paths, to use a different link. For example, for network A, if we want to go to the destination network C, we have two routes, we have two ways. One way is to go to A, go to B, C, D, and E. The other way is to go to A, B, G, H, D, and E. So we can use the TE to control the traffic. 70% of the traffic we will use this way because we can see this link is larger. The bandwidth of this link is larger than this link. So this link will be the primary link, and the 30% of the traffic will go this way. This way, the bandwidth of this way is lower than this way. And also for network B, the same. We can use traffic engine to control 70% of the traffic to use the primary link and 30% of the traffic to use the secondary link. Okay, now let's go to the next chapter. MPLS basic principle, MPRS control plan and forwarding plan. So this is the MPLS network model. In this model, we can see here, this is the MPRS domain. MPRS domain means the routers that running MPRS protocol. So in this domain, we have several rows of MPRS router. First row is LER. LER means level edge router. Level edge router. So in this network, we have two LER, router A and router D. They are two LERs because router A and router D, they are at the edge of this MPRS domain. Okay, and the other row is LSR, level switch router. So all the other routers, router F, router G, B, C, and E, all the other routers in the middle, they will be LSR. And another concept is LSP, level switch path, LSP. LSP also we can call it tunnel. We can also call it tunnel. Okay? Because when we give our IP packet to the MPLS domain, to the LER, the LER, it will push a label to this packet. And when this packet is forwarded in the MPLS domain, it will always with the label. So the packet is label switched in the MPLS domain. And this path from the source to the destination, from router A to router D, this path, we call it LSP. From the source to the destination, we call it LSP, and we can also call it a tunnel. And the MPLS control plan and forwarding plan, this is a model, the architecture. So for the control plan, first, routing protocol. What's the function of routing protocol? So the routing protocol can help us to calculate the routes, to learn the routes, to build the IP routing table, And at the IP routing table, can help us to build the IP forwarding table. The IP routing table and IP forwarding table, you can regard them as the same thing. Once IP routing table is in the control plan, IP forwarding table is in the data plan. Actually, they are the same thing. When we need to forward the data, we need to use the IP forwarding table. But the IP forwarding table, it is it is the same with the IP routing table. Okay, and then we need the label distribution protocol. Label distribution protocol. Why do we need this? Because we want to build the label forwarding table. The label forwarding table. Why do we need the label forwarding table? Because in the MPRS domain, MPRS domain, we don't need to use the IP routing table because we don't process the IP header. We just need to process the MPLS header. And in the MPLS header, we have label. We have the label. So we just need to check the label and to search the label forwarding table to find the outgoing label and the next hop, the outgoing interface and the next hop. Then we can forward the MPLS packet to the next hop. Okay, and continue. Let's look at when we receive an incoming packet, what will happen? First, if we receive an incoming IP packet, for example, this is an LER. LER is label switching edge router. So the edge router, it will receive the IP packet. When we receive an IP packet, we will search the IP forwarding table. We will search the IP forwarding table. When we search the IP forwarding table, there will be two situations. One situation is this IP packet doesn't need to go to the MPLS terminal. So we will search the routing table and outgoing IP packets. So it will be the traditional IP forwarding because this packet doesn't need to go to the MPLS terminal. The other situation is this packet needs to go into the terminal. For example, this packet, the destination is the terminal's end, is the end IP address, is the destination IP address of this terminal. So we have to give it to the MPRS terminal. So we will outgoing the labeled packet. It means we will push an MPLS header to this IP packet and then forward it to the next hop, Okay, so when this packet goes to the next hop, for example, the next hop LSR receive an incoming labeled packet, So this packet is with the MPLS header, and then it will search the label forwarding table. When it searches the label forwarding table, we will find that what is this incoming label? What's the incoming label? And we will find the incoming labels entry. And this entry, it will also have two situations. One situation is if this LSR is in the middle. It's not in the edge, it's in the middle. So we will find the outgoing label and swap the incoming label to the outgoing label and then forward this packet to the next hop. So this is in the middle, the LSR. If we are not LSR, we are LER. We are the end of the MPLS terminal. And when we find the incoming label, we find there's no outgoing label, and we need to pop the MPLS header. It means we are the last hop of the MPLS terminal, so we will pop the MPLS header and then continue to process the IP header and forward this IP packet based on the IP routing table. Okay, so that is the control plan and forwarding plan of MPLS. Continue, let's look at the MPLS label format. For the MPRS label format, we have two kinds of modes. One is frame mode, the other is cell mode. And cell mode is only used in ATM. So we will not discuss this mode in this lecture. So this lecture, we will learn the frame mode. For the frame mode, let's look at this. This is a traditional layer 2 frame format. The payload, then the IP header, then the layer 2 header, the frame header. Sometimes it's PPP, sometimes it's Ethernet. Okay, so for the MPLS frame, we will insert a MPLS header between the layer 2 header and the IP header, the layer 3 header. We will insert an MPLS header. So this is the format of MPLS header. The length of MPRS header is 32 bits. 32 bits, and the most important part is label. So because we will use this label to forward the MPRS packet. And the next field is EXP. EXP is used for QoS. And S means bottom of the stack. Bottom of the stack, because MPLS header, it supports the nesting. The nesting means we can have multiple MPLS header. We can have multiple labels. So how can we know this header is the bottom of the stack? So we can check the S. If the S is 1, it means this is the bottom of the stack. This is the last MPLS header. If it's not 1, if it's 0, it means we still have other MPLS headers after this header. Last field is TTL. TTL is used to prevent the loop. So it's similar to the IP header, TTL. MPRS label nesting. So we know that we can have multiple MPRS headers. It supports the nesting. So for example, we have level 1, level 2, and level 3. So in the level 1, the S bit will be 0 because it is not the bottom of the stack. On level 2 also, S will be 0. In the level 3, the S will be 1 because level 3 is the bottom of the stack. Okay, and the applications of label nesting is MPRS VPN and MPRS TE. In MPRS VPN, we have two labels in MPRS VPN. One is outer label, the other is inner label. We can also call it public label and private label. Okay, next, MPLS forwarding process. Now we need to learn two concepts. One is FEC, the other is NHLFE. FEC stands for Forwarding Equivalence Class. FEC is a set of data flows with certain common characteristics. These data flows are processed by the LSR in the same way during the forwarding process. In the same way during the forwarding process. What does it mean? It means, for example, you have 100 packets, and these 100 packets, they have the same destination address. They have the same destination address for this 100 packets. So this 100 packets will be the same FEC, since they will belong to the same FEC. It means in the MPRS network, when we need to forward these 100 packets, we will use the same way. So that is FEC. The other concept is NHLFE, stands for Next Hop Level Forwarding Entry. Next Hop Level Forwarding Entry. So the NHLFE is used for level forwarding. It will guide us to forward the MPRS packet. It will tell us what is the next hop of the packet, how to perform a tag operation. A tag operation, we have three operations. One is push. This is always been done on the ingress. On the ingress, we don't have any label, so we will push a label to the packet. And pop. Pop is always been done on the egress. On the egress, the last hop of the MPRS terminal, we will pop the tag and use the traditional IP forwarding. The last is swap. Swap is used in the middle in the LSR. Swap means we just swap the one level to another level and then forward it to the next hop. So the NHLFE will guide us to forward the MPLS packet during the MPLS terminal. So this is an example of FEC and NHLFE. We can use display MPRS LSP include 10.2.0024. So 10.2.00/24, this is an FEC. This is an FEC. So all the packets want to go to this destination will belong to this FEC, 10.2.00. And for this FEC, what kind of NHLFE should we follow? So let's continue. The NHLFE, it will be the next hop is 10.1.1.2. And in label is none because this is the ingress. So the in label is none. Out label is 1030. So we will push this label to the packet. Out interface 0, 0. And the label operation is push. So this is one NHLFE used for this FEC 10.2.00. Okay, so let's continue to look at the MPRS forwarding in the ingress LER. On router A, ingress LER, when we receive a packet 10.2.0.1, so this is an FEC. This is an FEC. So we will check the table to find the FEC is 10.2.0.0. When we find this FEC, we will continue to check the NHLFE of this FEC. So the NHLFE is the out interface is 0, 0. And the label operation is push. It means we will push a label to this packet. And the out label is 1030. So we will push the 1030 label and send it out from 00 to the next hop device, router B. Then continue. The router B is the transit node. Is in the middle. So on the router B, we will search the ILM, stands for incoming label map. Incoming label map table. In this table, we just search the in label, because router A sent a packet to router B and the in label is 1030. So we will find the NHLFE of this in label. We will find the out interface is 0, 3 and the label operation is swap. And the out label is 1032. So we will swap 1030 to 1032 and send it to router 3. When router C forward the packet continue to router D, and on router D, we will still the same. We will search the label switching table. And in the label switching table, we will search the in label, and we will find the in label is 1032. And for this in label, we will find the corresponding NHLFE. The NHLFE is label operation is pop, and there's no out interface. So on router D, we will pop this label and continue to use the traditional IP forwarding to forward this packet to the destination network. Okay, that is all. So now let's look at two questions. First, which field in the MPRS header is used to identify the stack bottom level? Because the MPLS header, it supports nesting, so we can use CS field to indicate whether this header is the bottom of the stack or not. Question number 2. Which of the following actions can be performed when packets are forwarded based on MPLS levels? There are 3 actions. First is push. This is always used on the ingress LER. Second is swap. Swap is used in the LSR in the transit node. The last is pop. Pop is used as the last hop is in the egress LER. We will remove the MPRS header and then use the traditional IP forwarding. So finally, A, B, 3 options. So let's look at the summary of this lecture. First, we learned the background of MPRS VPN, the background of MPRS. Why do we need MPRS? Because at the beginning, we want to speed up the forwarding speed of the data. Second, we learned the basic concepts of MPLS. We have LER, LSR, and LSP. MPLS packet formats and MPLS forwarding principle. And we will use the label switching table to search the label switching table to forward the MPLS packet. Okay, that's all of today's lecture. Thank you.